Yeah, so let me know if you guys are able to access my, I just published notes. We can decide whether we want to do the Notion. Last time we were thinking um, what to do, right? Like, should we use the Google Docs or something? Then, I'll just post it here. So folks, how do I post it? I'll send an email, right? Oh, the Discord. I don't have the Discord installed on my
Yeah, you can use Discord in the web too if you want.
chat in Zoom, is it? Yeah, it's there. Okay.
It's that too. Yeah, you could
Yeah.
just drop it in the chat.
Right. Yeah. So can you access that?
Yeah, sure.
Okay.
Let's see here.
Hey, what's that? I don't know. Notion. Yeah. Okay. Yeah. Yeah. So this is what my notes was after I read the first chapter. Yeah, I mean that it's basically very concise. But yeah, I mean we can probably, now is the time we can decide whether we want to go with the Word or this format. What do you guys think?
I'm okay with anything, honestly. I feel like it comes down to comfort level and understanding, right? I understand the Cornell notes system, which you have right here, notes, and then the keywords and then the summary. If
Yeah.
others are okay with that, then fine.
Yeah, I think I'm okay with it.
Okay. Yeah, so let's continue with you want to bring up, so last time we paused at
The last time we paused at like tools to look into and
right.
databases, caches, search and this. I don't think we actually like talked about these yet. We spent a lot of time on talking about just reliability, scalability, maintainability, Redis, Kafka versus SQS, and Memcached. So I think like these were discussions that we had from the group. If I go back here, I think this is where we are, and we can probably jump to maybe like this, image here, or we can also, I think like we can probably, jump to this page, reliability.
Minutes, right? Yeah, reliability. Yeah.
So like I put some highlights in here just because like, now that we've kind of gone through the 3 points, reliability, scalability, and maintainability, reliability, they kind of deep dive into it, right? The next part of the book chapter is just like deep dive into reliability, deep dive into things like human error versus software error, just hardware. And then after that, they go into the section about scalability and load, and then, what does that mean? And then how, they had like a diagram about Twitter, an example about Twitter doing tweets, an SQL call, and we can get into a lot of this. I just am kind of like outlining the chapter. And then I think like they finally, end with maintainability, and how to like be simple and evolvability. So these are all, again, like great points. If we finish this part today, then we're in good shape for chapter 2 next, which is about data lakes. So
yeah,
let's jump into this. So I'm gonna just start off by asking, like, I think we do a good job by just kind of like having discussions. So number one, I mean, in your own mind, like, I think, what did you kind of get from this section? Like, did you kind of understand like the things they were talking about, like, errors, faults, making something fault tolerant or resilient? Who here has experience doing those things or understands what that means?
Basically you're asking what are the how do you define reliability, right?
Mhm.
Yeah. So for I mean, in my mind, I see reliability as basically trusting the API or whatever that you're basically the system to do
Mhm.
the right thing for a given user input, or for the way it is designed to, right? Like if it's an API, if it's a post API, it updates the resource that we are asking it to update and not anything else. I mean, if it's a get, it should not be updating anything. So it's basically sticking to the contract, and does what the user intended to do, and not leave any unintended side effects.
Mhm.
Um, so that's one. And of course, the latency should be acceptable. And yeah, the author talks about unauthorized access and abuse, which is interesting. I didn't think that that would come under reliability aspect, but it's interesting. Yeah. So
Yeah.
there's
Y- Yeah, a lot of good points there. So actually, I'll break down mine like afterwards. But I also just want to like ask a few more people to give their input as well. Like, what do you think, Akanksha or Srini? I think you're joining us for the first time.
Yeah. Mm. Uh, I think reliability is reliability from a user experience standpoint. We're not breaking the trust of the user who is using the system, whether it's honoring to the expected behavior from a user standpoint, even if we cannot honor to the expected behavior, but still like handling the unknowns from the application side as well in a way that user is not surprised,
Mhm.
which will cover everything. It's not just the application performance or the expected output, but also covers security, uh, everything.
Good stuff. Yeah, definitely. Um, let's see here. I wanted to ask you too, Akanksha, actually, before I go. Akanksha.
Yeah, sure. So I
Yeah.
think for me, reliability means like things are working in a correct fashion.
Mhm.
Even when things are going wrong in your system, your errors are being handled correctly and you're not showing a wrong result to the user or anything.
Mhm.
So your system is reliable, right? It's showing you the correct results. Uh, so that's what reliability to me is.
yeah.
Yeah. Yeah, so basically, right, like I think you guys are all hitting it on the right the proverbial nail on the head or head on, I don't know how to say. It's the morning, I can't say it properly, but anyway, you're saying it the right things here. I think basically when I was kind of reading this, like my understanding was, you ultimately want to make something that, no matter what happens, like you can count on that service still being around, right? Like you could, you know, blow up your whole like system on one region, but like you'll have like another region with the same exact like available service. You know, I think it's kind of funny because he said if the entire planet Earth or all servers were swallowed by a black hole, this is probably the only time that you wouldn't have any kind of reliability. But it's just being fault tolerant or resilient, just being able to anticipate things can go wrong. And then you if you want to like make sure that your system is you know um is going to be good, you develop kind of like a failure tolerance. And so like the fault tolerance that they call is kind of like the thing that you see like in Amazon sometimes, like they'll advertise like the SLA, like how reliable is their system. They have like I forget the number of nines, but like maybe you guys know. I think it's like 6 nines or something like that, apparently, for like how often they're available. um and like if you increase the rate of faults by triggering them deliberately, then essentially you're testing to see like if your service is more reliable. Like you're basically like handling for error. So that's kind of like what these pages were about, like just like how well do you like handle, failure in your system, the tolerance level, how, that your system will allow for failure. The better it is, like, the better the system. And I don't know, like I haven't seen Chaos Monkey, but I was just gonna ask, like, has anybody here actually like seen this?
I haven't seen the, oh, it's a series or something. Okay. We do something like this. It's called game days in Amazon. So we basically take out a dependency, see how. So that's a point that I'm
Nice.
mentioning.
Nice.
So the definition of resiliency should include the system auto recovers. So when a component goes down, right,
Yeah.
it does not leave the entire service in an unusable, like when the component recovers, the system should auto recover. So that's another thing, like it should not completely break down or go in an unused, the data should not go in an unusable state.
Beautiful.
So
Yeah.
that's an important tenet, because you should expect that dependencies will go down. So when the dependencies go down, you should throw the right errors. So you should not like completely freak out. So this is, yeah, the error. So yeah, error propagation is an important aspect. Like the user should be communicated as to what exactly happened and what is expected of him. If there is nothing, then tell him that it's down and they should wait. And so sometimes if it's use, when something doesn't work, people tend to use it more in a hope of maybe a retry will make it work. So when such things happen, your system, the tolerance should be able to, your tolerance systems should protect the service from browning out. So error handling is an important part of resiliency and recovery. So while designing the systems, we should keep in mind how the system will recover. That's, yeah.
Beautiful. Oh yeah, at one point, I just wanted to ask also here, like, does anybody here want to volunteer to write notes? Since we're all kind of having the discussion at the moment.
I'm adding to the Notion thing, but
I
I
know.
add to the
Contributing a lot in discussion too. So I was wondering if we can get somebody who may want to just kind of do the note taking, like just handle that as well. But I have no problem. If you want to do it, you're totally fine. Like
yeah,
okay.
We can all edit the same thing, right? So I put it in there, so you guys can feel free to edit it. Yeah.
You're doing this one or
This one. You want me to do this one? Whichever. That's what I wanted to hear from folks. What are they comfortable with?
let's continue with this. I know that you like Notion a lot, but I think that this has already been shared to many different channels on Discord and WhatsApp. So
but this particular doc, I did not have write permission. So
oh really?
edit permission had requested.
Okay. It says anyone on the internet with this link can edit.
Okay. I don't know. The last time I did, I was not able to.
Oh, okay.
Okay.
Yeah, can you post that in the chat? So yeah, last time I'm asking, so what can people vote on, Word or Notion? Which one did you, or Vijay?
I feel Notion is a bit more organized. Probably we can have separate pages for different chapters.
We can, yeah, I mean, like, here's the deal. Like, I can take this, right? And we can start using this, and we can just kind of say, like, we're no longer using this, and I can make an update. It's not a big problem. I was just going to say, I have already shared this everywhere.
Okay.
People who attend today may not know.
Right.
But that's it. And think about it this way, right? Bringing it back to the chapter, like if we take away this component, what will happen to the system? And we introduce a new component, right? So there you go. How will the system, like, how will we continue the study group going,
Yeah. Okay.
Yeah.
Yeah. So I think we can trust Notion to keep it.
Okay.
So yeah, anyway. Okay, so I added that definition. I don't know if it's auto updating. Do you have to refresh?
Are you talking about Notion or are you talking about?
Yeah, I just updated it with that resilience aspect and fault tolerance, basically. Yeah, it is updating. It's updating. Yeah.
I'm not
Okay.
able to update Notion.
Oh, you're not able to update. Yeah. Okay.
Yeah, I think we do not write accessibility.
All right. So see, this is what happens when you introduce a new feature. It's a great
A
idea,
learning curve.
but it
Yes.
hasn't been tested in production
Can you try now?
yet. Okay. All right. This is probably why like so many companies are like pushing back on new features until like it's really, really tested.
Hey,
Yeah.
so no, that was my fault. I didn't enable editing. I just did. So can people test and tell me if they're able to edit?
Yes.
Oh, nice. Okay.
Can you share the Notion link? I'm not sure if you share it as well.
I can't. Oh yeah, I can see edit button now. Yeah. Oh, I have to log in something.
All right.
I don't know. I mean, data organization, I suck at it. If there's a tool that can help with more readability, I definitely not a fan of Word docs. So anyway, okay, so let's continue, right? Yeah.
Okay. So I'm QA confirming that I can edit.
Good. Okay.
Okay.
How will you share the Notion link?
It's in the.
Here, I'll go ahead and update Discord too. All right. So let's go ahead and put this in here. Team moving to using Notion. Please update your notes. All right, here we go. So just briefly too, the system design is our channel just for people who, I see like maybe a few people got the idea, but like this is where I've been kind of keeping notes. I know people were asking on WhatsApp, but you know, just like I said, I feel like Discord is a little easier to use because it's like Slack, has like video integration and audio integration, and plus finally like it's easy to use on a computer too. WhatsApp is something you have to use on a phone.
Yeah. Okay.
So we're basically, I think you said, where did you write your note?
Reliability idea. So resilient when components die and recover upon fixing the component, right? So
okay, right here, I see it. Perfect. All right, cool. Okay, so yeah, that was kind of like what I got out of this. I actually am interested in finding out if you all watch this show. Like, I don't know how popular Netflix is all with you, but like, you know, if you do watch Chaos Monkey, you find this thing, let me know, because I'm probably gonna watch it too at some point and like a discussion around that. So basically, yeah, I think we kind of got the idea from that section. It's about fault tolerance. It's about removing components. Like we just did a little exercise here about that, and then making sure that the system can still work. So yeah, we introduced a new component called Notion. It works, and so we're using that in lieu of using Google Docs, which has been more reliable for us. So let's talk about hardware faults. Now, this might be something that I think like our team probably is not as used to, because I don't think any of us work with hardware. You know, like I might be wrong here though. It's like, I don't know if you all are using hard disks and RAM and power grids and unplugging things on purpose. But yeah, just maybe like your personal experience. Like, do you have like a hard drive set up at home? You know, do you like play around with like, you know, the cloud? Do you have like accounts there? What's going on?
I work in a payment processing company. It's quite surprising. I mean, before that, I worked in Citibank. We never had hardware failures at a network level. But in this company, I see quite a few times the switches fail. And that too, you know, while someone is swiping the card.
Okay, yeah, correct.
The network switches fail, but I have never seen anything on the application side of it.
Okay.
Or, we have these interconnects with our cloud providers. Sometimes there is a hardware failure on those devices where they host this interconnect devices.
Well, what is like usually the error? Like, why is it failing?
Yeah, it's unknown until, because we look at hardware failures as the very last root cause. We try to, because when there is an error, everyone looks at, like, we waste an entire day to look at the end-to-end stack of applications, and then they realize and they raise a ticket, okay, there's something wrong. And even I'm surprised the data center guys don't get notification of such failures, or they might get, and they might thought that there is a redundancy for the applications that are dependent on that. So unless until it becomes a 7 ticket, it doesn't pop up. So yeah, I would say we were pretty bad at handling the faults. Generally, hardware faults, I don't think so. They're very handled at an application level.
So usually you would get like Java IO, if it's a Java application, you would get IO error, right? Like wouldn't you, what kind of errors would you see? Like wouldn't the exceptions point to you that it's been a disk error or something?
So generally this happens right in the payment switch before the transaction, before it comes to application side of it, because there will be network switches before our servers, right? We don't get the transactions. But from a client side standpoint, they have sent the transaction, they have swiped the card. And we check the logs, we didn't get any transaction. We find it, oh no, something is missing on the load balancer side, and they will troubleshoot on the load balancer side. No, we also didn't get it. Then, because it's very rare to say that it might be a hardware failure, because it's very uncommon. But here I've seen at least 2 failures per year.
So don't you monitor on client side? Usually when that happens, right, for us, we look at the errors that clients are reporting, and we look at the load balancer errors. If they match up, then we know like at which hop the failure happened. Right.
It has to be on the service provider, right? Because if the transaction is coming from an external load balancer, maybe a DDoS provider, if it is coming from a Akamai or some Cloudflare, and if he has to handle our network failures, our hardware failure, because switches might be the first point of entry.
Right.
Or maybe because within internal also we have the switches. So these, you're right, maybe the network, the Java input output exceptions, they might not know. They might think that it's still an application error. But not generally, it's very difficult for them. I don't know, but it might be very difficult for them to identify it's a hardware failure or something.
Right. So this is actually interesting, like as far as like how like you break down and diagnose the error, like you have the application layer. Because you're correct, Java can tell you, if that's the language you're using, like if there's an IO error, but then also, like maybe before it gets to the application, you have to kind of look at the network and the switches and all that too, and see like what's going on there.
I started an initiative just for this, just collecting all the assets of an application, starting from the network load balancers to the end of the stack, right? I was surprised. It's an impossible endeavor to do that. Just to collecting the data, forget about creating a dashboard and having those health checks and monitoring. Just, I want to know, like we were creating a network diagram. I said, I really need everything, each and every device. They said, it's impossible. No one knows that, but it's still working. The whole system is working for so long time, but they don't have that data.
That's kind of like, that's scary then. That's kind of like unreliable, right?
But it is very, very common in big banks. Very common because of this mergers and acquisitions, and the reorgs, and the people move out, the critical people mod. It's very difficult. If it works, I mean, they only look into it. Sometimes I call this, even this is also comes under reliability, right? If you cannot handle some fault, what do you do? Because if the cost of handling a failure is exorbitant, you take an insurance.
Oh, you take an insurance? Is that what you said?
Yes, we take an insurance, right? Because we know that we cannot handle that. So we have an incident. That's how even AWS.
Money.
Yeah.
Money is the most reliable system.
Exactly. At least, if you look at from a user experience standpoint, yes, the system is down, but I'm not happy. So how can I make you happy? I cannot bring down the system. If I know, I wouldn't have even let it down. The only way is I can just, pacify you is, yes, we're going to compensate for your time that you have spent. Okay, you're reliable. I really like that service. You keep, it's a word of mouth you say, right?
You get a gift card.
You get a gift card.
Okay. All right. Well, good discussion.
Even if you give a gift card, I wouldn't go to a system that is expected. So I need money. I'm in a critical state. You give me a gift card, something that didn't work. 2 days later, that's not reliable, right? I need money right now. So anyway, yeah, basically, yeah, the bottom line is that failures are expected, and you should fail gracefully and be able to recover once the failure is handled and root cause and handled. So, but yeah, it like the book also is saying, you should always have hardware redundancy, like RAID and stuff, and yeah.
So actually, like real quick, so I don't touch a lot of this, because it's not my job. I'm more like writing, in the application layer. But at home, I have lots of computers. I don't know. It's just I don't know why I do that. I have a bad habit of buying computers. I have a gaming laptop. I have this MacBook. I have another Mac Mini in my room, and that's my server, right, for everything. I put all of my data I've had over the years all on that. And so then every computer that I have in my house, all the iPads, all the phones can access that little server. And then the server can access every single one of these laptops. So, if I move anywhere around the house, I'm able to access my data. And I always think what if that machine goes down? Then I need to make sure it's backed up on another machine. So I make sure that it's backed up on this laptop or, on a separate drive. So I think we do these things here, or at least I do, without really thinking about it, but we're kind of doing the same thing that they're doing more at the higher level. We are I know that, hard disks crash, I know that RAM becomes faulty. I know power grids have blackouts, and, I've dealt with stuff like being unplugged. So, I know about this stuff, and I'm always backing up. I'm always trying to adding, more backups, more disks, and just play around with some of these laptops. Next time, maybe I'll do a little tour about that. But it's funny, when I was reading about this, I was like, I get this. It just makes so much sense to me. So I just
that's the value addition Dropbox brings, right?
Mhm.
So I have Dropbox installed on all my devices.
Yeah.
And so yeah, it's there, it's on the device, it's auto syncs. So basically you want a system that backup should also be put in sync, right? Every time the data writes happen so frequently, so all of that data sources should remain in sync. So I think that's the selling point of Dropbox, and it's a I'm a power user of Dropbox.
Yeah, definitely. Dropbox is game changing. And yeah, I have a OneDrive, and I have pCloud, and I think I have many different services that I subscribe to, because I'm just always, thinking about oh, what if I go to some remote area, and I don't have my, anything, I just have my iPhone, can I still access my data? And the system that I've set up actually does work. Yeah, I can still access, some of the cool stuff I have, on my computer or whatever, these days I'm just trying to make sure that everything that I have is in the cloud, all my books, right? You guys are looking at, my Kindle, all of my books are there. And that's a service I really appreciate about Amazon, so I don't really buy physical textbooks.
So I actually have an interesting experience where I had to design a system where it is not 100% reliable. Because, sometimes, because if you're looking from a technology standpoint, we want reliability, 100% reliability, backup on top of backup. And in majority of the cases, at least in my experience, what I've seen is it's not worth to have that kind of reliability, because you're not going to make that kind of money in that. I got one product manager. Oh, I want my system to be up and running 100%. Okay, we'll do that, but let me send you a bill, how much it will cost you. Oh, that's too much. But yeah, your expectation is too much. But we have promised the client, let it happen, because it's not coming from his pocket, right? It's coming from a central IT.
Right.
And they're not worried about that. But end of the year, they come to, okay, they ask me to reduce that, right? So then I have to enforce them. I know you have asked, but it might not be a need, because do you have any SLA that you promised for the clients? No, we just say that it's available. Then why don't you come up with an SLA? And if they want an SLA, because you can make money out of it. If they want 100% reliable, you can charge for them, depending upon how SLA. Because just for your application, I cannot make this happen. It's one data center. If it goes down, then we'll come up with the MTRs, right? If we cannot stick to the MTRs, then maybe you can compensate the client. But just for the sake of having it's too much of cost, and it's too much of maintenance as well.
Yeah, absolutely.
And with cloud, it's very easy to waste money. Actually, if you don't know, if you're looking technology at only one aspect,
right?
But if you look at holistically, then we can make right decisions. What's good for the business?
Yeah, that is a downside, right? Like if one common thing that I've seen and I've experienced myself is like if you have like an AWS account and you just let it run, without like looking at it, it'll keep charging you, right? You keep charging you a bill, and you're right. Like maybe sometimes you don't need that much level of reliability. You can get away with like just having like a shared account or shared hosting account somewhere else, that's a little bit cheaper, especially for like, application needs. Let me just kind of move on here just because of time. So I think like we got a good basis of understanding from here, and this is pretty good discussions about like reliability and like disks and backups and the strategies towards that. Like again, I guess the last point here is like, what do you do if the system completely goes down? You have like no no like backups or anything like that. What exactly do you do in this case? And so I would say like if you're interested in this discussion, just continue to read this part of the chapter here and maybe like add to the discussion notes afterwards. I think this is pretty cool here, what we have like this, like if we run out of time, sometimes maybe we can continue the discussions here. We can continue the discussions here. If you don't even have an idea right now, but it comes to you in the shower, definitely put it here in the chat too, because that way like it'll we can keep these conversations going. So another part of this chapter is software errors and bugs. And I think this is something that we're all more accustomed to, like, because it says we usually think of hardware faults as being random and independent from each other. One machine's disk failing does not imply that another machine is going to fail, but there may be weak correlations such as the temperature. Another fault is systemic error within the system. Such faults are harder to anticipate, and because they're correlated across nodes, they tend to cause many system failures, like uncorrelated hardware faults. So software bugs, right? The leap second in 2012 caused many applications to hang due to a bug in Linux. So, a service that the system depends on slows down or becomes unresponsive. Again, like maybe just wanted to ask you, or maybe ask some of the other people here on this, who just joined too. What kind of experiences have you had with software errors? Like what is like the thing that comes to mind mostly like in your career so far? Like, like have you had anything kind of crazy happen with a software or an application you designed?
I've seen something with timeouts. I mean, timeouts are very important for cascading failures. So there was a system where we were dependent on, when we configure the timeout from a client standpoint. We were the client and they are the servers, and we were the servers for someone else.
Sure.
So we timed out, and we responded with server is not responding, right? And then the whole thing came down to the server that we were dependent is at fault. And this has been running for so long, and we had timeout, right? But they retried it from our client side, and it worked. But sometimes it bubbles up and it will become a big issue. And the thing what we found out is we didn't respect the timeout of the server. These many years it worked, but in our addendum they already mentioned because some of the jobs are long running. We have to wait more than the default timeouts. It is expected that's the system, but we always configure our default timeouts as, I mean, even though HTTP default is 120 seconds, but for performance we only configure as 30 seconds as a default. We did it. And from our, I mean, if you look at from our standpoint, they have timed out, but it's actually, we didn't wait enough for them to respond.
So how did the timeout like ultimately occur? Was it just because the machine, itself, caused that, or was it something that somebody forgot to configure? What was it? What was the issue?
It was just contact communication, right? I think in the beginning she was telling us this was the time when there was no proper contract negotiation, even though it's in the SOA world, right? We communicate with BizDels and XSDs. There were no proper contract communication at an implementation level. Maybe they had at a business level, but they didn't have the communication level. And this is a shared server. It's very difficult for us to configure based upon the use case. And they also don't know that. This is the problem again with the shared servers, right? Not every application teams tells us what to do and what to configure, right? We just go with the default things. But their business, but their systems were, they require minimum 90 seconds of timeout.
So it was a contractual error. It was kind of, you pointed out like the reasons why these things could happen, right? Like, and it was, we could probably argue that it was, human.
Human errors, yeah. And this will bubble up in microservice world, right? This was in a monolithic, it happened once in a while, but this might happen very frequently in microservice. And the more distributed it is, the more cascading failure. There is a possibility of cascading failures a lot. And it becomes important to handle handle such kind of things. And now we came up with something where anything before you go to production, a kind of a run book where we check, have you configured enough timeouts? And it should be visible for operation support. They know what would be that, and we have waited so that they can communicate with their upstream systems. And so that's what, and whenever we talk to the external vendors also, we make sure that they communicate all those things through their OpenAI specification, so that we just do that. We just implement whatever as part of the communication. So we are giving more importance to the contracts wherever the service contract is clearly defined.
Perfect. All right. Anyone else want to just jump in real quick? I might move quicker because we are getting closer to time.
I want to add a non-obvious point to the timeout thing. So yeah, for long-running jobs, it make you might want to configure something like 90 seconds. You expect that the downstream service is doing something with it. So the other perspective is that for not so long-running jobs, like for example, Elasticsearch cluster, right? You are expecting a fast indexing result from the OpenSearch cluster, but for some reason, some node went down or something, and it's taking longer. So one reliability technique we can employ there is timeout on the request processing. So what happens is, like, for example, you are looking up someone, autocomplete, and it is going and querying the OpenSearch cluster or Elasticsearch cluster, right? And it is so because of this issue, it's not able to come up with a response. But people keep bombarding it, people keep entering, and like each keystroke is a request. So your result for a previous keystroke is irrelevant for the next request. Sure. So for the services, for such a system, it should not process a request that's like past so much time, like what are the
like a run rate or something. Yeah.
So if you keep processing everything in a sequential order, basically you're going to go down because people are going to send you more requests. So that configuration was a very that was a revelation for us.
Like a circuit breaker pattern.
Yeah. So I mean, like the service itself should have a timeout on the request that it should only process the most recent ones, and it should prioritize processing the recent ones than the ones that have been waiting.
Makes sense. Yeah.
Okay. All right. Like I said, great discussions. Let's continue to have them like, afterwards as well, like as we move forward. I just wrote some highlights here. Basically, like, you want to design a system that minimizes opportunities for error. But the thing is, like, if you're designing, and which is a great thing, like this is like goes towards like, like if you write programming, a thing that I'm familiar with is test-driven development, where we usually say red then green, basically. Like, you first write a test and then like you say like this thing works, and then it doesn't because it fails, and that's the red error that you see in your console, and then you build in that implementation, and then it should be green afterwards. So that's kind of like the way I've been taught to develop. It's a good way of developing. But it says here in my highlight that if interfaces are too restrictive, people work around them. So you have to kind of balance this. It might be tricky if you make something too prohibitive for a user. They might get frustrated with it. So that's a good point. But unit tests, system integration tests, manual tests, I think these are things we're all really familiar with, but I'd like for people, who maybe watch this video afterwards, like, or whatever, maybe give some, commentary on your own experiences with this as well. And as well as like how you handle human error, how you minimize failure, just, what kind of configurations do you do? And then what kind of monitoring do you do? I think this is kind of like something that,
I have a question here.
Yeah.
Second point, you missed the second point, right? The decouple the places where people make the most mistakes, the sandbox environment kind of.
Thank you. Mm-hmm.
How do people do this? It's a great idea. Like you want to test your feature with the production data, but how do you do it? What are the techniques that people do to gather the production data in a sandbox environment?
So I can probably speak to this, right? Like what we do is we have like, for applications at least, we have different types of server environments. We have, a server that's pretty much like a clone of like the production server. We call that stage. And then, like it has the same exact configuration that production would have, but we can also change the production. We can also like enable like different feature flags, right? To basically like say, okay, this feature we want to like push to production is available on stage, or, we can have like another box that is also a clone of stage, and we can throw in some environment variables there. You can have as many number of, boxes as you want, like sandboxes as you want. And with continuous integration nowadays, it's like really easy to set that all up. So, we just kind of like play around sometimes with, environment variables and see like, this is what will happen if we, push this feature or we disable that feature. And that's kind of like how we do our testing. Anybody else want to add to this question?
How do you clean your data that is PII level? This is a continuous challenge we still face day to day.
Yeah, that's the most important aspect for us to have a sandbox environment more than an environment. Mm-hmm. It's like, we copy the data. I would say the sandbox itself is a separate discipline, and which is evolving now because of the agile world. We want everything like fast and quality. So yeah, there are some tools where data masking tools. We also use in production, right? We review before we duplicate the data from production to our staging environment. We review all the columns or the fields from the database with our information security officers, and based upon their recommendations, what we do is, but at the same time, we also have to have a valid business cases to test in non-prod environment. So what we do is we do tokenization, right? For example, if the account number is PCI data, we mask them, or we come up with duplicate values for the account numbers. And all other data, which is not PCI or PII, we just use as is. Like maybe if from our experience, there are 20 to 30% of effort to get that data copied into non-prod. And once you establish this as a process, because you cannot just do this for one of an application because it's too much of effort. Sure. But if sandboxing itself is a standard environment for your organizations, then it makes sense to have that kind of effort, because you have to have built tools, and you have to put efforts, and there is a dedicated team just to maintain a sandbox environment.
Yeah, and I agree with you. Like, you probably don't want to, like, I guess for us, we don't want to touch personal information. We want to avoid doing that as best as possible. If anything, it would probably be just, something like more like fake, but like it might use, anonymized parts of, data that we have clearance for, right? A lot of it still though is, fake until like real users use it, which is why we have like a separate entire QA team to handle that as well, right? Like, what are the user experiences? We kind of look at the logs, but we don't take people's personal information and play around with it like in sandboxes. That's kind of like, that would get us into a lot of trouble. But yeah, I'd love to hear about discussions about how people handle that. That's really interesting.
Yeah, I mean, like for example, I before AWS, I was working at Yahoo on an ad display team. So there was a need to actually test your code change with the real production data, and we didn't have a mechanism to actually replay the production traffic in a non-prod environment. Because there are the combinations of the user inputs were like are impossible to test, right? So it would have given us a lot of confidence if there was a way to play the production traffic on a non-production environment and test how the. But yeah, looks like the only suggestions I got was like people actually copy over like probably database tables or something, and then you just okay. But like what?
Yeah, so we have a service actually. Even like we have a system where like if you swipe a credit card, right, there are like thousands of rules that get executed behind these networks. Like we are also like a Visa, MasterCard. We have our own network, and we are also an abstraction on top of all these networks, right? So we have a rules engine that we maintain where it goes, every transaction goes through that many rules. And some of these rules are very critical, right? Before you move to the production, you really need to test this. So we copy the real data. And this is also, we consider this as a production environment, even though it is not live with the customers, but the PCI DSS controls are applicable for even for this testing environment. So what we do is we replicate the data live, not 100%, like, at least we leave 24 hours of data. Last 24 hours, we will not put it in our testing cycles, but we do a live replication with Golden Gate with the database toward the sandbox environment. And any change that we do in the rules engine, first we will test through this data.
Absolutely. All right, so let's move on. We're almost at scalability, which is great. The last point that I just kind of like made here was that, essentially that you have to test, you have to do all of the implementations that we were talking about, and you have to make sure that, you're not cutting corners. You have to make sure that your system is reliable. We've talked about like bugs and, outages and, strategies to avoid some of that, as well as, using things like sandboxes and test-driven development to like, make sure that your code is, tested for failure tolerance, fault tolerance. And so if you don't do that though, like you risk having like, your reputation and, losing money. So it's really important to, if somebody ever says to you, oh, how important is reliability? It's not that important. You can kind of like point them to this part of the book. So that's probably why it's, like they dedicated a lot of time to this. So let's move on to scalability. And to me, scalability is actually like the most interesting component of like these three, because I always think like, again, I opened with last time, essentially that we live in an age now where, if you have a skill, you can make a lot of money, not because, like you're good at that skill, but because you can scale that skill. It used to be like if you were good at like, like drawing like a picture or something like that, you know, you could share it with your friends or your family, but now you can share it with the entire internet, right? And if the internet scales and is reliable, right, then you can share with like millions of people and get like tons of followers to buy your stuff, right, for that same thing. So that's really interesting, right? Like a lot of people who can sing or, you know, dance or whatever get really famous. You're all familiar with TikTok and Instagram, so you can just look there. So it's an interesting thing. Scaling is something that I really want to deep dive into, especially with my career, and like understand better and better and better. So this is probably like the most important part of the chapter for me, at least. But essentially, yeah, like I think like the author kind of like started to talk about like, you know, if a system is working reliability today, that doesn't mean it'll necessarily work reliably in the future. And the reason is because of load, right? You know, if a system like a website is getting like 10,000 users like for traffic, but then it suddenly starts getting like 100,000 or a million, it may not be reliable enough or enabled enough to be able to handle that scale. So scalability is the term we use to describe a system's ability to cope with increased load, right? Like how much more you're gonna get, how much more traffic. Let's say you like do some cool TikTok dance, suddenly like millions of people are like bothering you about it. Like, how are you gonna handle that? So maybe like a point on this. Does anybody here want to talk about scaling? Has anybody dealt with scaling? You know, does anyone have a cool TikTok or Instagram video that went viral? That's okay. You know,
About the techniques for achieving scalability, right? You don't want to have a full-on scaled out service when you're actually starting out, right? You want to understand your traffic patterns. So basically, the techniques that you apply depends upon the application access patterns. So that's where the Twitter use case is interesting.
Mhm.
Yeah, because it's unique in the sense that the load happens when with particular users. So the more popular with a certain bucket of users who are followed by a lot of people. So those users are the ones. So basically, you can identify that whoever is following these people, like a certain celebrities, right? These guys are the load inducing users. So you can
Yes.
treat them, you can, yeah, basically, yeah, that's, yeah, the point is like you should understand the access patterns and you should design your system to scale according to that. Yeah.
Yeah, definitely. So the Twitter thing that you're talking about is this part in the book that they use as an example for, you know, load parameters. Basically, you know, this idea of like, what is the current load on the system? Again, like what is the current like, you know, scale or traffic? What are the requests? Like deep down, what does that mean? Like requests per second to a web server, the ratio of read writes to a database, the number of simultaneously active users in a chat room, the hit rate on the cache. These are the technical components of it. So in the idea of Twitter, right, a user can publish a new message to their followers at 4.6 requests per second on average, with 12K requests a second per peak. And so, you know, these are load inducing, you know, values on Twitter server. But then Twitter, you know, like originally had a scaling challenge, and it was due to not how much the tweet volume was coming through from users, but it was more to this concept of fan out. So I encourage you all to read it, like, or look at it again once more. Essentially, like each user follows many people and each user is followed by many people. There are broadly two ways of implementing these two operations. When a user requests their home timeline, they look up all the people they follow and find all the tweets of those users and merge them, right? This is the problem here. And so if you look at the example, and here's kind of like the SQL, if you want to deep dive into it, users currently logged in. So they're going to, you know, process this SQL statement, and, you know, they're going to try to join all the tweets, all the follows on the user, and then the user's followers as well. And they're going to try to load, where they're going to post this tweet and they're going to have it sent out to all of their followers. And this is basically it can if the user has a lot of followers, it can be kind of a problem for like the server. So I really liked this part about how they diagrammed it, and how he kind of went into detail about like how they could potentially do this example here. I think let's see here. Does anybody here kind of want to like add to maybe kind of like this example here, like what your thoughts or takeaways were, maybe for this particular notes? Let's see. So
yeah, I mean, it's so it's a good, I think this is pretty standard way of implementing, right? So you have a intensive, like latency intensive operation or something. You design it so that you don't do it in a API execution. You do it as a background process. Basically, that's what they're suggesting here to do. So that's the second approach, right? So you proactively do the work and don't do the work as a reaction to an API call. So that when you do it as a background worker, you have more control about more control on basically what you are stretching the limits of. Like, for example, if you see that your DDB is kind of throttling you, then database is throttling you, then you can kind of back out and then retry at a leisure, like and while still keeping you accept a latency hit, right? When you're doing in a background, then there is a latency hit, like the tweet might not show up in user's timeline within the next 5 seconds as fast as an API request would do. But it's acceptable. It's an acceptable trade-off in order to keep the system reliable, right? Like the system, it should scale and not go down, right? So yeah, that's I think that's a standard practice we do, right? Like we kind of push the CPU intensive or database fetch intensive tasks to background.
Right. Actually, I'm starting to remember, like, so this part here was essentially saying there are two ways of implementing this operations, right? Like, so this was the more load inducing or costly, approach for Twitter, right? Like just posting a tweet, inserts a tweet into a global collection of tweets, and then this is a costly, sort of operation. They have to like post, and then all these people are waiting here to get that newest tweet, right? Like, and so if they have millions of followers, it's going to take a lot of time for this thing to actually go out. Whereas if they pre-process it beforehand, which is strategy 2, and maintain a cache for the user's home timeline, then you're saying too, like it may be there may be a delay, or it may not be as fresh content as what the user may have actually posted, but that may be okay. And I think it helps balance the load of the system. The user still gets to see all of the tweets that are relevant when they come to their mailbox or to their home timeline. But yeah, essentially, they have to kind of balance it between both approaches. I think, like in modern day Twitter, right? Like, because any tweets from celebrities may need the approach of one, right? And then, approach 2 may be more fine for like, people with less followers. So I think it'd be really great if we kind of like, went through this part of the example once more, as an exercise, maybe like for homework or something like that, just kind of, like really deep dive into it and just kind of, maybe talk about it in the discussions again once more. It'd be really good to just jump in on that.
It's a generic technique, right? The takeaway from that example is a generic technique that whenever you have an operation that is not an action that is not latency sensitive, then it makes sense to do it as a worker job rather than do it in the API execution. So
Yeah, exactly. Correct.
And another takeaway probably is you cannot stick to one particular solution. You may want to follow a hybrid approach. So it may require, you may want to think about more than one solution to come up with the solution what for the problem you have at hand. So it's like a combination of push and pull we have to use here, for example. Right. The ultimate solution.
Right, you're correct. Both of you are correct. Yeah, it's about like, you know, the processing, and then, you know, maybe also pre-processing. What can you move? What parts of the process can you move essentially to, like, you know, a background service task or worker task, while, you know, still being able to, you know, keep the essential tasks that need to be done going, you know, for your application, so that your followers or your users can be happy. So it's a pretty cool example. I think
so it's Sadhana's point, like it's basically a combination of push and pull approaches. But even with the pull approach, you can usually, if it's a downstream service that's doing the push, and they say, I'm not going to implement an API to push an update, then you are basically stuck with pulling. Then, and at the same time, you should not bring them down. So at that time also, you should this batch, basically the worker approach, is a better approach to follow. Did I make sense?
Absolutely.
So yes, absolutely. When you have a system, I mean, at least I recently faced the similar kind of an issue where another team was handling a component where they were not ready to build a small API for us to kind of listen to an event kind. They were not ready to push it. So we are kind of now stuck with the problem of we have to pull it, but how do we do it efficiently? So we try to do it once in a day, considering we did it be 5 minutes once, considering how much of what is the tolerance level we have with respect to that data. Every 5 minutes level was good for us. So that way we were able to update it.
Yeah, good discussion.
Hey, so it is 8:35. I apologize for rushing a little bit towards the end. I did actually want to like spend a little bit more time on the Twitter and all that, but it is 8:36. So we'll go ahead and stop for today. And then we'll just try to pick up and finish out like the rest of this chapter, you know, Monday. And like I said, let's try to have the discussions, you know, in this channel, as well as, you know, contribute to the notes here, you know, or to the Notion notes. Now I'll close that. Contribute here, and then, you know, that way we can continue to, like, you know, talk about our experiences and our understandings of things, and then move forward towards chapter 2, which will be on data.
Yep.
Okay. All right.
Hey, so do you want to do the chapter 2? You want to go sequentially? That's another thing. I don't know how much of this database design people would actually enjoy reading. I mean, is it relevant? If you are a database engineer, it is. But I'm wondering, like, does that immediately add value to you guys?
So the whole book is valuable to me. I feel like.
I mean, yeah. So, of course, it is valuable. So basically, I was thinking chapter 6 was like directly relevant to chapter 5, actually, distributed data. Starting with replication. So that's where the distributed systems, it's handling the data across multiple dimensions. But yeah.
Maybe, yeah, that is absolutely right. So probably the first 4 or 5 right? We can probably take it up later on as well. It might not be too very. From the chapter, I think it will become really challenging, or we can actually discuss about more on the experience each one has had with respect to the distributed systems. Of course, we can come back to this.
Yeah, I mean, that's what I think, but yeah, we have it's a small group, so we should be able to address everybody's yeah. What if you have read it already, is the understanding in chapter 2 needed for chapter 5?
Yeah, I mean, so I think maybe we should take a vote, or maybe we can do it, offline as well. Like if we want to move to chapter 6 first, that'll be fine. I prefer sequentially though.
Chapter 5, so stuff like JSON, XML, and formats of encoding evolution. Like I don't know if it's going to be useful at all. Second and third, maybe.
Actually, I did go through the second chapter, so some parts of it is definitely useful. Say, for example, they start with the comparison of relational model versus the document model, and then they try to explain how exactly you can model different relationships. Say, for example, one-to-one mapping, many-to-one mapping, many-to-many. So,
okay, yeah, let's do that. Okay.
But later on, yeah, perhaps it might not be useful for us. When say so, I mean, I haven't gone through the complete chapter, but it's good. But I do not know if maybe the distributed systems chapters will be more challenging, and to hear the experiences of different people, right, is probably more value add over there.
Yeah.
And let's do chapter 2 because there is some value to it. And it is, and then yeah, we can decide on chapter 3 when we come to it.
Yeah. So we can probably take a vote on all this, and we can definitely see like if we want to like mix up the approach we use for looking at the chapters. And so I would just I would err on the side though, like, again, of just going sequentially, because like, some people are going to jump into this, some people are going to like jump out, and I think like it would be great if we just had like a rolling series of stuff that we've already covered. So if anybody is like, oh, I missed that particular video or that chapter, can you talk about it? And we can go back and look at it, so again, like it may not be relevant, but at the same time, like it could be later, right? It may be not relevant to the point right now in time, but I think like just going over or reviewing it in general is a good idea.
Yeah, maybe we can just skim through, not spend too much time on those, right?
Okay. All right. And I think like the good idea, like in terms of like, getting through the chapter, if you feel like it's a part that is, very lengthy, we can just kind of go through the bullets, or we can like defer later to having, discussions afterwards, like in the Discord where you have more time.
Sounds good. Yeah.
Okay. All right. Oh, well, great job everyone today. Good job waking up and doing this, and jogging your memory with all this, and hope to see you on Monday.
Yep.
All right.
Thank you.
Thanks a lot. Bye.